Hello differential equation students. Let's take a look at how do we solve higher order linear differential equations using variation of parameters. So what is this variation of parameters? This is not section 4.4, by the way. I think in your book this is section 4.6. So for our purposes I'm going to go with section 4.4. So what is this variation of parameters? The variation of parameters is basically when you have a non-linear higher order differential equations that are either constant coefficients or non-constant coefficients, you can find the solution. Mostly you can find the solution, the general solution, we know that the general solution for a non-homogeneous higher order differential equations with constant coefficients or non-constant coefficients is going to be y is equal to yc plus yp. This variation of parameters deals with finding yp. It doesn't deal with the yc, it deals with how to find the yp. So how do we find the yp? And usually again this process is mostly very useful in a case, for example, a problem like this where you cannot find the annihilator on this side. If you can find the annihilator, of course you can solve it, but you can't find the annihilator. And then you have a problem here that has non-constant coefficients where we can't use our M&Ms and annihilators, right? So how do we do that? So let's take a look at the second order non-linear non-homogeneous linear differential equations. If it is y double prime plus p of x y prime plus q of x is equal to f of x, right? Suppose this is second order, right? Second order linear differential equations. We know that when I say this equal to 0, right, that is going to have two linearly independent solutions, right? Homogeneous problems are going to have two linearly independent solutions, which we usually call them F as fundamental solution set as y1 and y2, right? So that's what this one says. Suppose y1 y2 are solutions to this right here, that is a homogeneous version of that differential equation, then yp, that's very crucial here. Then the yp is going to be some function of u multiplied with the y1 and another function of u, another function u2 multiplied with y2. And how do you figure out this y1 and u1 and u2? And there's a whole process. If you can look at the book for the whole process, but if you simplify, then simplification becomes where u1 prime, not the u but the derivative of the u, which is u1 prime, is going to be w1 over w, which is y2 times the f of x right here, divided by the w, and the u2 prime is going to be w2 over w, which is, if you simplify, it's going to be y1 times the f of x divided by w. What are these? W, w1 and w2, right? This w is the determinant of remember the Wronskian, we talked about it at the linear dependence independence, right? That same Wronskian is what the w is. And the w1 is, what do? You replace the first column. You replace the first column of your w and replace it by 0 comma f of x, right? 0 comma f of x. The w2 is, take a look at the w, replace the second column by 0 comma f of x, and that's a w2, and you do the determinant of that. Then actually you can do that. I want to quickly note one thing in here. When you solve a differential equation, in general the second order differential equation is going to look like this, right? It's going to look like this. When you use this Wronskian method, you need to make sure that it has to be in this standard form. It has to be in this standard form, and that standard form by which I mean the coefficient of the y double prime has to be 1. Otherwise, this is not going to work. So you need to transform this. If you have an equation something like this, right, you need to transform this into this way. What do I mean by that? For example, if you take a look at this particular example number 6, right? Example number 6. You see here the coefficient of the y double prime is not equal to 1. So what do you have to do? You need to transfer this into this form. To do that, you need to divide the entire equation by x squared plus 1, right? And then you're going to have y double prime minus 2x over x squared plus 1, y prime plus 2 over x squared plus 1, y, and that is going to be equal to 6 times x squared plus 1, and this is your f of x, and that will be your f of x. You cannot just take this one as your f of x. right? Your f of x would be after you divide this. Make sure that the coefficient here is 1. Then whatever you get on the right hand side, would be your f of x, something that you should know this. And how does the process work? The process is very simple. It's similar to what we have been doing all along. The process is basically you find the y1 and y2, right? If it is given to you, you find the y1 and y2. And once you find the y1 and y2, then you find the w, and you identify your f of x. You find this one and you find that one. Then you can find the u1 prime by doing this, and the u2 prime by doing this. Sometimes this involves a little bit a little bit of algebra, and also you have to find the u1, which is basically integration of the u1 prime. That requires some little bit of extensive integration. Same thing with the u2 prime, that also requires a little bit of extensive integration. Then you plug it back in, and then given your y1 and y2, you can find the yc, and now you have your yp. So your yc would be c1y1 and c1y1 plus c2y2, and your yp would be your u1y1 plus u2y2, and your u1 here is a function, and u2 here is a function, and then we get the u1 through this process right here, and we get the u2 through the process right here. And that's about it. So I'm going to solve how to do that. I'm going to solve this problem in the next video. I'm going to solve how to solve this particular differential equations. In this case, the second order linear differential equations, where you can find you cannot find the annihilator for that one. And also in the next video, I'm also going to find the solution to another example, and that would be I'm going to solve y double prime minus 4y prime plus 4y is equal to x plus 1 times e to the 2x. So in the next video, you will see how to solve these two problems. I will stop it right here, and then I will show you how to work with this one.